Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll talk about absolute value inequalities involving a less than sign, where we have an absolute value less than a positive number. So in this first problem, we've got absolute value of x plus 5 is less than 7. I want you to think about what type of numbers have absolute values that are smaller than 7. Well, we know 6, 5, 4. The positive numbers that are less than 7, their absolute value is also less than 7. How about a number like -1? The absolute value of -1 is +1, that's smaller than 7. -2, -3, they work. When we get to -8, though, we run into a problem because the absolute value of -8 is +8, and that's actually greater than 7. So what we need to do here is we need to trap that expression, x plus 5, between 7 and its opposite, -7. So we're looking for values of x plus 5 that are greater than -7, but at the same time smaller than +7. And to solve this inequality, we've worked on this before. Subtract 5 to isolate x in the middle branch. We're left with -12 is less than x is less than 2. And that's our solution. Now, the way that we present these solutions, they can be done in a few different ways. We can use set builder notation, the set of all x such that -12 is less than x is less than 2, which is basically what we just had, right? Then we can also take a look at a number line. There's 2, there's -12 to the left. We want x to be between them, so we're going to shade in between -12 and 2, but those two values are not included because there's no equal sign in this inequality. It's what we call a strict inequality. So we're going to use parentheses at those two endpoints and shade between them. In interval notation, this is -12, 2 inside parentheses. Now, this first absolute value inequality that we had, the absolute value was already isolated, but if you look ahead to the next problem at the bottom of the screen, that's not the case. The first thing we have to do is isolate the absolute value, then we can trap it and solve. So the first thing that we're going to do here, we need to add 9 to both sides of this inequality. And we'll have 2 times the absolute value of x minus 4 is less than or equal to 26. We'll divide out the 2. And we have absolute value of x minus 4 is less than or equal to 13. Now we have the absolute value isolated. Now we can trap that expression between -13 and 13, the value that we had and its opposite. -13 less than or equal to x minus 4 less than or equal to +13. We can add 4 to all three branches of this inequality. -9 less than or equal to x less than or equal to 17. As in the last problem, we can do this in set builder notation, the set of all x such that -9 less than or equal to x less than or equal to 17. On a number line, put -9 and 17 onto the graph. This time we're going to use square brackets because those endpoints are included. This is a weak inequality. So square bracket at -9, square bracket at 17, shade between. Finally, interval notation would be bracket -9, 17. All right, that's how you solve absolute value inequalities involving the less than sign. In the next video, we'll take a look at what to do when it's an absolute value greater than a positive number.